Okay, yippee-ki-yay, mathletes. Today this is section 19.1 in the book, and we're talking about the limit, and they'll say things like as x approaches 0 from the positive side of 1 over x. Yeah.
What is the thing about OBX?
Right, that is shorthand, and this stands for LIMIT, the word limit. So you'll see that lim as x approaches, as x approaches approaches 0 from the right. Okay? Because it says the positive side, and this is the function 1 over x. See you later, Katrina. So watch this at home. CHS Math Party. Yeah. Okay? So this is the shorthand that we use. So let's talk about this function 1 over x. You know it. You love it. It's hyperbolic. Okay? Let's talk about this. So Forrest, excuse me, you're new. So if you want to watch this video, you just go to CHS Math Party, College Algebra Trig, and then click on the Moodle page. It's right up on top. And then scroll down. It'll say section 19.1. So you can watch it, if there's nothing else good on. Okay? So let's talk about this function then. So we can have our good old xy coordinate plane, and f of x equals 1 over x. What does this do? What does this function do when we graph it? What does it look like? It has asymptotes all over the place. What does it look like? Okay, in quadrant 1, what does it do, Tucker? Eh? With sound effects? Okay. Okay. Goes like that. And then, Renee, what were you babbling about? It goes same thing to quadrant 3 like this? No. Okay. Okay, so then we could say it's reflected about what line? This is a bonus. This isn't part of anything in our class, but what line is that reflected about? Ooh, Brian. It's reflected across the line y equals the opposite of x. Very good. And that's a bonus. That's nothing special, just to say. Okay? Now, so this is the function. So we're going to say, what's the limit as x approaches 0 from the positive side or the right side of the function 1 over x? So here's 1 over x. And we're saying as x gets closer and closer to 0, which is here, what's happening to y? Really, that's what we're saying. As x gets closer to 0, comma, what happens to y? That's really what we're saying with that notation. As x gets closer and closer to 0, what happens to y? What's that, Kai? Mucho gigante. Right. Yeah, it gets really, really big. And the way we say that then is the limit as x approaches 0 from the positive side of 1 over x equals positive infinity. Now we have to be a little careful with infinity. It's not a number, Santiago. Infinity is not a number, it's a concept. Okay? So, we got to be a little careful. Okay? Now, it's positive infinity because positive infinity is the infinity up here. Okay? Let's look at the other side. Okay? It's alter ego. The limit as x approaches 0. Office Human, what up? No, she ditched. She's probably out behind Roth's doing something. Not here. Okay. The limit as x approaches 0 from the negative side or the left side. So now we're over here. We're getting closer and closer and closer to 0. What happens to y as x gets closer? Mucho smalo. Buen español. Negative infinity. Pequeño. Yeah. Nice. Okay, now we're feeling good about ourselves and think, oh, we have it down to a science now. But we don't. How about the limit as x approaches 0? 1 over x. Riddle me that. Batman. What about that one? The limit as x approaches 0, the function 1 over x. Yeah, it makes you uncomfortable. It makes you lose sleep at night. Yeah, Ty, what do you think, man? Okay, I have a both answer. Other input, plus or minus infinity. Brett, what do you think? 42, we have a bunch of answers. What could be undefined, that's the closest answer yet. Does not exist. Is that a Mean Girls quote? And you thought all that screen time was a waste. See, there you have it. Okay. Why doesn't it exist? That's a great thing. In mathematics, and we'll see this next year in the calculus, if it's ambiguous, Forrest, if it's ambiguous, we typically say it does not exist, or in some cases it's undefined. In this case, as we approach 0 from the left side or from the negative side, it goes to negative infinity. As we approach 0, the same point, from the other side, or the positive or right side, it goes to positive infinity. Because of this conflict, we say the limit does not exist. And sometimes this is the answer, but be careful. Sometimes it's easy to just whip that out and say, oh, it doesn't exist, when really it does exist. Okay, so be careful is all I'm saying.
Oh, it doesn't exist.
Yeah. It doesn't exist. So we say, and this is the limit. Remember, it's the limit of this function. Does not exist. Okay? Will? Oh, it depends. There are so many. And we'll do a bunch of more examples. There can be all kinds of different limits for different functions. So we just have to do a bunch of them. Riley? Right. The function. Pardon me? Well, no. We just say it does not exist. This is infinite here. This is infinite here. Okay? Right at 0, it does not exist. Okay? Right. Okay? So it doesn't exist. Who are you waving at out there, Levi? Have him come in and visit and do math with us. Okay. Let's try some different ones. Phoenix?
So I'm confused on why it's positive infinity and negative infinity.
Oh, okay. We can back up. That's a good question. Right. What direction am I going here?
You're going left.
No.
Up.
Up. And up in our world, and we just chose it, up in our world is what sign? Positive. So we say this is going towards positive infinity.
Okay, but I thought that one was talking about as it approaches 0 from the right.
As x approaches 0 from the right, which it is.
Oh.
See, this is the right side. Okay? Okay. No, and I'm glad you asked for clarification. That's good. Okay? Now, let's do some other ones. I don't want to go crazy. How much time are we up to now? We're at 10 minutes. We're doing good. Okay, I will make this fast. So let's do another one, like the limit as x approaches. I need an example. Can't think of one off the top of my head, so I'm going to steal one out of the book. Need a function. Oh, here we go. This will be fine. The limit as x approaches infinity. Okay, let's do one of those. Of 2n to the third minus n squared, I like this one, over 3n cubed plus 5n. Okay, now, if we have one like this, we can think about what happens. And keep in mind, infinity is really big. Okay? Which part of this is going to dominate? Is just going to be the 800-pound gorilla. Which part of this will dominate? Amy, what do you think? The exponent 3, gosh, I don't know, is perfect, Amy. How little confidence supplement every day, girl. Yes, that's perfect. Okay? The n to the third, when you take infinity and cube it, this infinity squared is going to be like nothing. Okay? It's not. Oh, it will, but it's not. Be careful. Infinity isn't infinity here because we're not there. Where are we? We're approaching infinity. And there is a difference. Contact man, Zach, what do you need? Oh, n in this case. You're right. Thank you. That was just me. He's right. If that blew you away, I apologize. Okay. I was just getting in a hurry. And thank you, Zach. So, as n approaches infinity, keep in mind, we're not at infinity, but we're just at a really big number. Okay? We're not at infinity because we're approaching it. We're not there. We're at a really big number. So, when you take a really big number and you cube it, it makes this number here look tiny. Okay? Because it's cubed. This, as Amy said, will dominate big time. Beat the crap out of this. This becomes insignificant. This becomes insignificant. Only thing that counts, and again, we don't have infinity. We just have a really big number. Cube it. We have another really big number, equally big. Cube it. Brian, stay with it. This is heavy. Huge number cubed divided by huge number cubed. What is it? No. 1. This becomes 1. Huge number cubed divided by that same huge number cubed is 1. Okay? These guys here won't matter, okay, at all. This becomes just a blip on the radar. Riley, let me finish. So what is all that we have left? No, well, we have 2 times 1 over 3 times 1 is what we have. Okay? These become insignificant.
Why is that?
Because compared to this, they are nothing. You can't even see them. These guys are so gosh darn big. Think of it like a circle, okay? Think of it like 2 times a big circle, or big sphere if you want. Okay? And down here you've got 3 times that same really big sphere. Okay? And this is n cubed, and this is n cubed. And now over here, here's n squared. Here's 5n. Really, think of it like this. Do these matter? No, they're just a minor annoyance because, again, we're not solving anything. We're just saying, what's the limit? As these guys get really, really big, and if these aren't big enough, make them bigger because they can go as big as you want because you're approaching infinity. This n squared, who cares? This 5n, who really cares? Okay, Riley. Oh my gosh, all over the place. It's massive. I mean, for right now, to be able to do the calculus, but all kinds of computations involve this, especially really small things, subatomic level, and really big things. So especially astronomical things. If you're trying to deal with anything really big like astronomy, look at the Hubble, the Kepler, space telescopes, gravity bending light, all kinds of stuff like that, or little tiny subatomic things. They deal with this. So particle physics, it's awesome stuff. And I think it's just cool to wrap your head around. Okay? Bill.
So the numbers aren't really big, they're 1. So why wouldn't
They're 1 after you divide it. So, I mean, basically what Abby's saying is you've got 2 times this. And put the n squared on there, all right? 7. That's like the n squared, okay? So this part here, and I'm just making this up, this is like n cubed. This is like n squared divided by 3 times, if you want to put numbers in, and maybe that helps. Okay, that's like 5n. Okay, really, that's what it looks like, okay? That's like n cubed. Do these guys matter out here? I mean, really, what does this equal here? No, it equals like 1.00000001. Okay? When you take 10 billion and 7 and divide it by 10 billion and 1, it becomes 1.000000, or it becomes 0.9999999, right? And so this is really what dominates. The n squared, who cares? The 5n, who cares? Okay? And if you don't like this, put a bunch more zeros in there until you feel comfortable with it. But when you take a really big number with some other crap at the end, and a really, really big number with a little bit of something at the end and divide it, it's going to be close to 1 every time. Zach? Ouch! You're dividing. You can do that, but again, do this part first because it's really big, okay? And however big you think it is, go bigger. And you think about this part first, and the n cubed dominates. Kai? Well, you can't get there. Okay, so you approach infinity by taking the biggest number you can think of. Okay? Now add something to it. Okay? That's what you're doing. And then whatever number you just said, add another number to it. Okay? And it does, and you're chasing it. And that's what we call approaching infinity. Don't let it wreck your brain too much, because people have written the whole doctoral theses on infinity, and maybe still are just starting to get it. It's a trippy topic. Point being, all of this becomes very close to 1 as we approach infinity. Okay? So what's left? Okay? So we say the limit is 2 over 3. The limit is 2 over 3. Okay? And the fast way for you to do that without making yourself crazy is just, if this is the same magnitude as this, whatever coefficients are out here are going to be your limit. If these aren't the same magnitude, let's do one like that. Okay? What's that? Oh, you can, but we want to be more elegant than that, Renee. First, yeah, yeah. Don't do that on your calculator. Do that in your mind. Yeah, do that in your head. And then that's better. That's a lot better. Here's one. The limit as x approaches 1 of x squared plus 2x minus 3 over x squared minus 1. Okay, so no problem. We've just got a solid number here. This is great. We just plug in 1 squared plus 2 times 1 minus 3. Great! Over 1 squared minus 1. No biggie. But what does that equal? What does that equal? Come on, help me out. Well, we have 1 squared is 1 plus 2 is 0 over 0. This is called indeterminate. This is called indeterminate form. Okay? And basically, it's not saying it's undefined. It's not saying an error. It's saying we don't know yet. Okay? Indeterminate. So that means we can't determine it. That means we must manipulate, which is kind of violent, I know. That's fun, right? So this is the limit as x approaches 1 of, let's factor this. What do you get? All right, one at a time. Okay, what are the two factors of x squared? X and x. Then you go over to the 3. Only the 3, not even the negative. What are the two factors of 3? 1 and 3. Then you look only at the negative sign. What does it mean? One's positive, one's negative. Then you look only at the positive sign. What does it mean? Which one's positive? The 3. The bigger one has to be positive to make this positive. The bigger one's got to be positive to make this negative. One of them's got to be negative. One's got to be positive. Check it. X squared 3x minus 1x minus 3. Does it work? Put a Brian by that. You're the Czech man.
Oh, yeah.
You're Czechoslovakian. Okay, here we go. Now, if at any point you get something like this and you see this, bells go off in your head and you go, ooh, ooh, that's cool. Why? Yeah, because this is a special case trinomial, and you can use, if there's any way you can get one of these to be the same on numerator and denominator, go for it. What's the other one going to be? X plus 1. There we go. Good. So now we're cool. Now we can say the limit as x approaches 1 of, these guys can divide out, x plus 3 over x plus 1 equals what? equals 1 plus 3 over. Remember, Phoenix, I saw what you were trying to do there. That's only when this is x approaching infinity. Okay? So be careful. And this is, and also that's only when you have a coefficient multiplying out here, Phoenix. Adding doesn't matter. Over 1 plus 1 equals 4 over 2 equals 2. The limit is 2. The limit is 2. As x approaches 1, y approaches 2. Right. Okay. Now we're at 25 minutes, so I'm definitely going to want to stop this, and you're going to want to do a bunch of practice problems. Okay, so goodbye.